Okay, here goes some examples for lesson 15, which is our last lesson in fractions for now. We might move on a little bit further in April and May, but for now we're just going up to lesson 15. In this lesson, we are still comparing fractions, and so here we're comparing 3/4 and 4/5. What I taught the students was what I call the trick, which is the easiest way, in my opinion, to find which of these fractions is greater, less than, or if they're equal to each other. I'm also going to show you exactly what that means when we do the trick and how to show and prove that answer as we complete it. So first, here's the trick. It's pretty simple. It just goes 4 times 4 is 16, and 5 times 3 is 15. 16 is larger than 15, and so 4/5 is larger than 3/4. That's just the basic trick. If you didn't have to show work and just looking for an answer, that's all. This is all the student would really have to show on their paper. They would then write, they would eat the 4/5 and they'd put that and they'd be done. But in order to really show exactly what they're doing and explain what they're doing, basically what they did was they made 4/5 into an equivalent fraction. They multiplied 4 times 4, which is this number here, and they have to do it to the denominator, 5 times 4, and so 4/5 is equivalent to 16/20. Over here, what they really did was 3 times 5, whoops, it should be a 5, which is 15, and 4 times 5, which is 20. So they basically just multiplied the 3 and the 4 by 5 to make an equivalent fraction. So now really what they did was 15/20 is less than 16/20. The last step would be to show this using a picture or a model to show this, which is a little bit trickier. That's not too bad. We have 2 holes and we're using an area model. In this first hole, we are dividing vertically into 3/4 and shading in 3 of those 4 pieces. In our second model, we're shading in 4/5, but we're going to do this one horizontally. In order to show fifths, we need 4 cuts. 1, 2, 3, 4 cuts horizontally, and we shade in 4 of these pieces. 1, 2, 3, and 4. So this was our original fractions that we started with. Now what we did in this first fraction was we cut it into fifths. So we cut this fraction into fifths. So really we take these 2 models and we kind of are combining them into one, and we're kind of merging them together. And so we cut this into fifths here, so we're going to cut this into fifths just like we did over here. And it's horizontally 1, 2, 3, 4 cuts will give me fifths. Over here we started with 4/5 and we cut it into fourths, and so we're going to do that the same way we did this model. And to cut fourths we do 1, 2, 3 cuts. So basically we created an area model with 20 pieces, an area model with 20 pieces. This area model has 5, 10, 15 out of 20. This model has 4, 8, 12, 16 out of 20, and so we would eat the one with 16. So 3/4 is less than 4/5. So this is really the full explanation, not just the trick, but showing with numbers that we made equivalent fractions and showing with models how we came up with those equivalent fractions. This is absolutely necessary for adding and subtracting fractions, which is a 5th grade skill, and this is definitely something that Mr. Hill wants the students coming to him having some experience with. Obviously he goes over this, but it's just a great trick, and it's a really necessary move going forward in fractions. Now just to show you a couple more examples, here we have 5/3 and 7/4, which are both improper fractions, but the same trick works. And so really the trick is just 3 times 7 is 21. And I like it when the students write the number up here. It shows their work, and it just helps them eliminate some mistakes and lets me see that they're not just writing down answers, they are solving. They don't have to have these arrows right here. I just do that for now. 4 times 5 is 20, and so they would eat the 21. So 5/3 is less than 21, and so these arrows might not be there. They would have their symbol in there showing less than, and they're eating the 21. A couple more times here, same thing. Down here we're going to do the same thing. We have improper fractions. 4 times 7, and it's really, this is equal to 28/20. We're really just multiplying both of these by 4, and then we're multiplying this numerator and denominator by 5, so this turns into 30/20, and 30/20 beats 28/20. And you can see now we have common denominators, so we could do 30/20 minus 28/20 is 2/20, and could be reduced to 1/10, which is already basically working up to the 5th grade, maybe even 6th grade skill, just by making both of these fractions into equivalent fractions with common denominators. The last one, the numbers will start to get larger. 5 times 8 is 40. 5 times 12 is 50 plus 10, which is 60. 12 times 3 is 36. And 12 times 5, again, it should have a common denominator of 60. And we're going to eat 40/60 instead of 36/60. You can see the numbers start to get large, and so I told the students that eventually we don't want to draw pictures. We don't want to make 40, 50 pieces and shade them and cut them. We really just want them to know quickly and accurately how to compare two fractions or two improper fractions, and then we want to carry this skill over to 5th grade to start to use with adding and subtracting fractions with unlike denominators by making them common denominators. So definitely my favorite trick for fractions. I save it to the end, and at this point everything's going to become just a little bit quicker and easier, but hopefully they have a good understanding of what it is we've been doing. And this is lesson 15. We're going to review lessons 12, 13, 14, 15, and take just the final little quiz before we move on from fractions. So we've done a great job, and they seem to pick up well on this on the first day, but we also will do this for another day at least, just to make sure that everyone has a deep understanding of this. Please feel free to post any questions or comments or email if you want more examples of any of these problems. Thanks.